We are going to start with the recording. I'm going to share back the screen. Okay, now can you see the PowerPoint here? The blank PowerPoint? Okay, good. Okay, so we are going to start by just giving you some brief what are the main idea in the pressure and also temperature, okay? So okay, for the temperature part, the most important thing is to know the difference between temperature, what? Degree of temperature and also temperature different. Okay. So why? Because normally in any kind of question, the student has some possibility to get confused because the way you answer temperature degree and the way you answer temperature different is a bit different. So it's up to you how you interpret the question, you know. And there are few tips that you can use in order to differentiate between temperature degree and temperature difference, as what I mentioned in the video of lecture. But we are going to also do some exercises today to see the difference. And for the temperature degree, normally it's about the that specific temperature. Let's say what is the room temperature? 27 degrees C. And then change the room temperature from degree C to Kelvin, let's say. You need to add 273. And then you change to, let's say, to English unit, to Rankine, let's say. So that's temperature degree. But temperature difference is the difference between two temperature. Eh? Let's say what is the let's say the baking the oven, yeah, the example of oven that I given in the video. Let's say the hundred, what is the temperature of the oven 10 hours ago. 10 hours ago, the temperature of the oven is 100, was 100 degrees C. And what is the current temperature of the oven is already reduced to 20 degrees C. So the temperature difference is from 100 to 20 degrees C is 80 degrees C. So that's temperature difference. So it's not specific temperature on that specific time or point. Yeah. So that's about the temperature. This is the main thing lah about the temperature, the topic of temperature. If you notice, these are the main thing. Other than that, it's just unit conversion and so on. And also for pressure is also have two things. The first one is the gauge pressure, and also the other one is the absolute pressure. Okay, for gauge pressure is something not related to the atmospheric pressure. For instance, like in the normally we refer pressure in the gauge kan. This is consider gauge lah. Say okay. So the needle will show the pressure. So this nothing to do with the absolute pressure by considering no atmospheric pressure interfere in the reading of the gauge. So that's why we call it as the gauge pressure or relative pressure. And in the same time, we also have absolute pressure, which will have to take into account the atmospheric pressure. Eh? So absolute pressure is the gauge pressure plus atmospheric pressure. And for the atmospheric pressure, the standard atmospheric pressure is 1 atm. However, this is not meant for all the atmospheric pressure because atmospheric pressure can change according to different conditions such as the longitude, altitude, and so on. Yeah. So like us in this area and in this area, maybe the atmospheric pressure is higher compared to those who are living in the Cameron Highland area. Yeah, because it's higher in the altitude. And because of that, the atmospheric pressure can be measured by using one device, which is the known as barometer. Barometer is specifically used to measure the atmospheric pressure. But if any question asked about absolute pressure but did not give you any barometer reading, that's mean you can use gauge pressure plus standard atmospheric pressure. Eh? In case if the question did not provide any info about the barometer readings, so we can just use 1 atm or 15 millimeter, uh, 14 millimeter mercury as the standard, as the atmospheric pressure. We just use the standard one lah. So this, and also we also learn about the manometer as well. And these are the things that you learn in the temperature and also pressure topics, which is what we are going to do related to the exercise today. Okay, so let's just start with the first part, which is the temperature. Okay, so the first question asks you to convert the following temperature to the requested unit. Eh? So we have four A, B, C, D. We want to change the temperature. So may I know whether this question is related to the temperature, degree of temperature, or the temperature different? Anyone can answer?
Temperature degree.
Temperature degree. Yes, correct. Because this is focusing on the specific temperature. Yeah. So it's very straightforward. What you need to do is just to convert lah. Let's say 10 degrees Celsius to convert to degree Fahrenheit. Yeah. So this is all do it. Just going to share here. Okay. Let's say for the first question lah. Um. Okay. So from 10 to 10 degree. Okay, okay. Okay, so we have 10 degree C. We want to convert to degree Fahrenheit. Okay, so how to convert? Do you need to memorize all the formula related to the conversion of this? Well, actually, it's already been provided in the conversion table too. If you see here, we have the temperature. You can just use this. Yeah, if you want to, in order to do the conversion. Of course, some adjustment might be needed to fit the type of unit that you want. But having said that, you have this, and some of you might ask whether you use 273.15 or should you just use 273. Well, it depend. Well, for me, I don't mind if you just use 273 instead of 273.15. The more specific, the better. But the answer for 273, if you just want to make it round number, I will accept it. Including for the Rankine from Fahrenheit also 460 is okay. It is acceptable. It's just want to round the number. Okay. So these are the formula that you can just follow in order for you to answer the question. Okay. So let's just try the first one first. Okay. This is 1A. So we have 10 degrees C. Want to convert to Fahrenheit. Okay, degree Fahrenheit, and also at the bottom degree C. So 1 degree C is equals to 1.8 degree Fahrenheit plus 32. So what you need to do is to do this conversion first. This conversion first, and then you can add or plus with some value as is the temperature degree has been mentioned before. So the answer will be at the end 50 degree Fahrenheit. Okay, so this is for number one. So number 1A, and for number 1B, we want to convert from 10 degree C to Rankine. Okay, so 10 degree C, now we want to convert to Rankine, degree Rankine. Okay, so again, the same thing, 10 degree C. We try to do the conversion first. 1 degree C is equal to 1.5 Rankine. Okay, this is just a normal conversion between SI unit and the English unit. And then we need to plus 32 and plus 460. Yeah. So at the end, you're going to get 510 degree Rankine. Okay, so this is cancelled. This will be cancelled. So this is the answer. 5. And C, convert from negative 25 Fahrenheit to Kelvin. Okay. So for this one, you can just refer to the formula. You need to first, uh, there are two ways actually. You can convert Fahrenheit to Celsius first, and then from Celsius you can change, uh, just add 273 to become in Kelvin. But in the same time, you can also do the direct conversion by changing the Fahrenheit into uh, Fahrenheit uh, to Rankine and then do the conversion. Okay, so I'm just going to do it plus 460. This is all will be, and then Fahrenheit. Okay, sorry. This is degree Fahrenheit. This is Kelvin. Kelvin is 1. And then the answer will be 241.6 Kelvin. Okay, and lastly, we have 150K Kelvin changed to degree Rankine. So for Rankine to Kelvin is just the method of multiplying or substitute with 1.8. So for this one, this is Kelvin. So 1 Kelvin Rankine. So the answer will be 270 Rankine. Okay, if you notice here, um, it's always like if you want to convert from SI unit to English unit, the 1.8 will be paired with the English unit, not the SI unit. So it will be always like this, regardless of whether 1.8 Rankine over 1 degree C or 1.8 Fahrenheit over 1 Kelvin. It's always going to be like this. Yeah. See, the English unit will be pairing with 1.8. So this is just a tip lah. If you confuse sometime in order to do the conversion. So this is some of the unit that you can just follow. Okay. So any question for question 1, A, B, C, D? I think it's very straightforward. Yeah. Okay. So question number 2, consider the interval from 20 to 80 degree Fahrenheit. Okay, so we want to consider the interval, the difference lah, the difference between 20 degree Fahrenheit to 80 degree Fahrenheit. Definitely, if we just going to minus, the difference will be 60 kan, 60 degree Fahrenheit. So here, we want you to solve this in two ways. One is to calculate the equivalent temperature in degree C and the interval between them. So the 2A question asks you to convert first 20 degree Fahrenheit convert to degree Celsius, 80 degree Fahrenheit also need to convert to degree Celsius, and then after that then you do the minus. Eh? Or the second thing is to calculate directly the interval in degree C between the temperature. Okay, so the second thing is to do the temperature different and then you convert to degree Celsius. Okay, so two ways. This is just to give you some more understanding the difference between temperature different. Yeah. Sometimes we tend to get confused between the temperature degree and the temperature difference. So this is a very good exercise or good practice to show the difference between these two. Okay. So let's just start with the first one, in which we need to change the unit first all to, sorry. Okay, so to A. Okay, so T1 is 20 degrees C. So we want to, sorry, 20 degree Fahrenheit. Okay, so okay, so 20 degree Fahrenheit, we want to change to degree C. And then T2, 80 degree Fahrenheit, we want to change to degree C2. So how to change it? So for 20 degree, you need to minus 32 and then multiply, divide by 1.8 degrees C. So at the end, you are going to get negative 6.7 degrees C. Okay. For T2, okay. So 80 minus 32 divided by 1.8 degrees C. So at the end, you are going to get 26.6 degrees Celsius. So T2 minus T1 equals to 26.6 minus 6.7 degrees C. So the answer will be 33.3 degrees C. Okay, so this is the first step. We need to change one by one. So the second set of question here asks if you do the you straight away calculate the temperature difference. Yeah. So here the temperature difference T2 minus T1 is equals to 80 degree Fahrenheit minus 20 degree Fahrenheit is equals to 60 degree Fahrenheit. And then this 60 degree Fahrenheit, we want to change. This is temperature difference, yeah. This is not a temperature. This is not a temperature degree. So that's why the degree of Fahrenheit here, we just do the, yeah. So this is a temperature difference. So 1.8 degree Fahrenheit is equals to 1 degree C. Just like this. So 60 will be divided by 1.8 Fahrenheit. No plus or minus 32. So you need to differentiate. So this is a temperature degree solution. This is a temperature different solution. At the end, you're going to get the same answer, which is 33.3 degrees Celsius. Okay, so this is for number 2. Any question? Do you understand the difference between temperature degree and temperature different?
Understand it too.
Okay, good. Okay, so the third question. Okay, the heat capacity. Okay, the question is quite long actually, but I already kind of like shorten it. The heat capacity Cp of acetic acid in joule over gram mole Kelvin can be calculated from this equation, where T is in Kelvin. So convert the equation so that T can be introduced into the equation in Rankine instead of Kelvin. Okay, keep the unit of CP the same. Okay, so if you refer back to the lecture video that I give, I also provide an example similar like this, but it's a bit longer, in which it has two steps. The first step is to convert this T from Kelvin from SI unit to English unit or English unit to SI unit, and then after that, the second step is to change the unit of the heat capacity. However, for this one, it doesn't require you to do the second step, which is to change the unit of this joule over gram mole K. because it's just stated here, keep the unit of CP the same. So what we need to do is to just change the T now. Yeah. So we skip the second step. Yeah. But make sure that you understand how the example work. Yeah. And I believe that you already also did the example and try to understand the first step is about temperature degree. We just want to convert the temperature degree. And then the second step is about the temperature difference, in which is related to many other units as well. For this one, we're just going to do the first step only because it's stated here, keep the unit of CP the same. If I change, the CP unit needs to change from joule over kg mole per degree C, let's say. So you need to do the change. But this one, we just need to keep the unit of CP the same. Okay. What we need to do, this is number 3. Okay, so the CP is equals to 8.41 plus 2.4346 times 10 power of 6t. Okay, so what we need to do is to change this T. Okay, this T is already in Kelvin, so we want to change it to the T is in Kelvin. So we want to change to Rankine. So what we need to do is to see the how to change it to Rankine. In which for Rankine, Kelvin to Rankine, what we need to do is to just divide it 1.8 only. If you refer back, this is temperature degree. Temperature degree for Kelvin and Rankine is just a matter of multiplying or multiplying or dividing with 1.8. So this is the formula. So what we need to do is just to include it here. Okay, so it's going to be like this. This is in Kelvin. So we want to change it to Rankine. Yeah, 8.41 plus 2.4346 times 10 power of 6. Okay, so the unit here is I'm not just going to, but this one T already changed to T R over 1.8. Okay. So you will have to divide this into this. Yeah. From this to this. This we're not going to change. So the final answer you get is 8.41 plus 1.353 times 10 power of 6 T Rankine now. Okay, so this is the final answer in which this have the same CP units, which is joule over gram mole K, kan? K power of 2. Okay. But later, if I want to ask the question, ask you to change this unit to something else, then you need to do the second step. But for this one, the answer will be until this stage only. Yeah. Any question for this one? I afraid that some of you might get confused. Any question? Anyone did not understand? So this is the final answer. How many of you got the same answer like mine? And I really encourage you to try the tutorial your own first so that you can understand more when I explain how to solve the question. rather than you just today you just listen to what the explanation on the solution of the question, and then later if you go back, if you try to do it your own, and you definitely will have some question ask to ask about this. So better if you can prepare first, and then during the tutorial session you have more question to ask instead of just listening today. Because for me the most important thing is to understand the concept behind of this, how to solve this, and do a lot of practices and exercises, because only then only then you know what kind of question or what kind of confusion that you have, that you need further clarifications. Yeah. Okay, so that's about the temperature. Any question for temperature before we proceed with the pressure? We already completed all the three questions.
I have a question, doctor.
Okay.
Why we have to divide by why the R have to divide by 1.8 but not times with 1.8?
Okay, yeah. So this is the very good question. Actually, I'm waiting for this kind of question from the student. This is been asked every single year. Okay, so that's why here we want to change. Well, basically, if you want to change from, let's say, TK, you want to change to, let's say the value of Kelvin, Kelvin, 100 Kelvin, let's say, we want to know what is the value in Rankine, right? So in Rankine, so what we need to do is 3 times 1.8, and then we're going to get the answer in Rankine, right? But for this one, what we want is to have the degree of Rankine temperature as the subject here. It's not the answer like this one. It's not straightforward as if the one that we solve in the first part, 1.1a, 1b, 1c, and 1d. Yeah. For this one, we want to have the T Rankine as the subject of this. So that's why Tk is equals T Kelvin is equals to Tr times 1 over 1.8. So this is, we just want to make sure that we want to have the Rankine as the subject in this. So that's why instead of times, we divide point 1.8. Do you get what I'm trying to say? For instance lah, okay, give you example lah. Okay, 100 Kelvin, we times 1.8 is going to be 180 kan? 100 Kelvin. If we want to convert to Rankine, we need to times 1.8. So the answer will be 180 degree Rankine. So it's not like we want to have the, let's say here, instead of T, just going to put 100 Kelvin. And then here, we change to 180 Rankine. Okay, so it's not going to be like this. It's not like the direct conversion. If you do this, then the TK, if you do this, the answer, the way to express it is T C T K 1.8, right? TK multiplied by 1.8, you're going to get 100 and 180 degree Rankine. But still here, it's still TK. It's not T Rankine. So we want to have the TR here. So that's why instead of converting like this, like what I mentioned before, what we need to do is just to go back to the formula and C, the subject here from TK, we want to change the subject to TR. So the formula instead of uh, TK times 1.8 is going to be TR over 1.8. So that's why here is going to be TR 1.8. Okay. Do you get what I mean? I know it's a bit confusing, but if
Yes,
you
doctor.
okay. Because I think
Thank you, doctor.
every student every year will ask the same question because they kind of like why we don't just use the formula and just put it here something like that. But just think like this, just think like this. The subject here that you want is TR instead of if we have the direct conversion like this, the subject here will still be TK, not TR. Eh? So that's why we use the formula here so that the subject will be TR. So it's a bit the reverse of the conversion. Yeah. So make sure that the TR will be here as the subject matter. Okay. I really hope that just go through this again and try to understand why I choose this instead of direct the conversion. Okay, and this is also a very favorite question that I will normally ask in exam or test. So just prepare lah for this kind of question. Okay, any other question? I assume I assume there is a no. Okay, so we are going to proceed with the second part of the tutorial, which is the pressure. Okay, so let's just go through the pressure. A pressure gauge on a welder tank give a reading of 1.54 times 10 power 5 Pascal. The barometer pressure is 28.6 inch mercury. Calculate the absolute pressure in the tank in. So again, when we ask about the absolute pressure, that's mean we need to add the gauge pressure and also the atmospheric pressure. And the atmospheric pressure here reflects by the barometer pressure. Okay. For me, the challenges in pressure type of question is the fact that you need to know the skill on in doing the conversion of the unit. Because if you notice, the conversion of pressure is a bit you need to do some rearrangement for you to answer the question related to pressure in different units. So let's just try to do the question on the pressure. Okay. Okay. So this one A. Okay. P absolute pressure is equal to P gauge plus P atmospheric pressure. Yeah. So what we need to do is to change. Okay, for the first question, it's asked to change. This is already in Pascal. This is in inch mercury, and the question asked to have the absolute pressure in pound force per feet square. So what we need to do is we need to change this unit Pascal to pound feet square and also inch mercury in pound feet square. So you need to refer to this conversion table to do that. Okay. So it's okay. We are going to do it now. Okay. So let's start with the first one. Okay. So this is P absolute equals to 1.54 times 10 power of 5 Pascal. So we need to change this. 1 Pascal is equals to 0.0208885 pound per feet square. Okay, so this is for the for the gauge pressure. plus the atmospheric pressure, which is the barometer. So 28.6 inch mercury, we need to change to 1 inch mercury is equals to 70.73 pound over feet square. So after you do the calculation, you will get the final answer will be 5239 pound feet per feet square. Pound force per feet square. So this is the final answer. You need to do the calculation lah. So later, if you try this at home, at college, so what you need to do is try to answer this. What is the answer for this one, and plus what is the answer for this? I'm just going to give you a simplified version of the solution, but overall it's going to be like this. But please do your own and do the calculation your own. Okay. So this is for 1A. For 1B, the question asked to change it in millimeter in inch mercury. So for inch mercury, so the same thing, PABS 1.54 times 10 power of 5 Pascal. 1 Pascal is equals to 2.953 times 10 power of negative 4 inch mercury. Okay. And for the atmospheric pressure is already in inch mercury, so you're just going to use the value. So at the end, you're going to get the final answer of 74.2 inch mercury. So this is for 1B. And for 1C, okay. So how I get this inch mercury and then pound? Again, you need to refer to this pressure, this conversion table. They say 1 Pascal. Okay, it's not exactly like 1 Pascal. You need to do some readjustment and so that it's going to fit. They say 1 ATM. Okay, the pound is in inch. It's not in feet. So you need to change first the feet. So 1.6 uh 96 pound in inch square. You need to convert this inch to feet square first, and then you get and then you compare with 1 atm. 1 pascal is equal to how many bar? Okay, so okay, so 1 pascal is equals to 1 1 newton over meter square. Okay. So that's why this is 1 PSI equal per gauge. Okay. So this is the way where you need to do the conversion. Yeah. It's not directly. You need to do some adjustment of the unit first in order. So that's why I say for pressure, the challenge is more towards the unit conversion, in which you sometimes it's a bit confusing and need to really apply all the unit conversion knowledge that you have in order to have this direct conversion. Yeah, it's not stated in the conversion table, but you need to kind of like rearrange so that you're going to get this kind of direct conversion. Okay. So the second question, a pressure gauge. Okay. Sorry, 1C belum siap. Okay. So for 1C, it's asks you to have in the feed H2O. Okay. So PABS equals to Okay, I think this is not something that you have in the conversion table. 1.54 times 10 power of 5 Pascal. You need to change this, but maybe in other conversion table you have, but it's okay. Just going to try this. 10 power of negative 3 inch H2O. Water, not mercury, it's water. And then the we need to change the inch into feet. 1 inch equals to 0.083 feet. But I'm going to make sure that all the question asked in the test and in the exam are something that you can find the unit conversion in the conversion table. Yeah, so don't worry about that. So for this one, 28.6 inch mercury, 29.92 inch mercury is equals to 33 point. This is equal to density actually, but it's I don't think you have in the conversion table that I give you. So at the end, you're going to get the final answer of 84.1 feet H2O. Okay, I found the conversion from Pascal to inch H2O in other conversion table. You can also Google to see the conversion. And but it is in inch, so that's why I still need to change to feet. We don't have this in our table, I think. No, we already have it in mercury, and in fact, mercury also is in mm. So if the question asks you to change to inch hg, so you need to change the mm into hg by do the normal conversion unit. Okay. So the final answer will be like this. Okay. Any questions so far for these three? Again, for pressure, I think the challenge is more towards the changing of the units, in which is a bit confusing. So you need to take some time to familiarize yourself with the conversion table like this and do the changes, so that you are going to get to answer the question easily like this one. Okay. Okay. So we move to the second question for pressure, in which for the second question, a pressure gauge on a process tower indicates a pressure of 3.53 inch mercury. Okay. The barometer reading is 29.31 inch mercury. What is the absolute pressure in the condenser in Newton meter square? Okay, so again, you need to see here Newton meter square. Okay, and then you see the conversion here is it is in millimeter mercury. So you need to change the millimeter to inch, and then you need to change to nanometer, Newton over meter square. Pascal, Pascal, Pascal. Okay. So the answer will be like this. But again, later if you have time, you please do and try to find the unit conversion your own and try to understand how it work. Okay. Okay. So question two. Okay. So it's about the gauge. Sorry. It's already gives you the gauge and also the barometer reading. So the absolute pressure is the gauge plus the barometer reading lah. Simple. Eh? So both are already in inch mercury. 29.31 plus 3.53. Both are in inch mercury. So we need to convert this to 1 Newton meter square. So it's equals to 9.5 Sorry. Two point nine 53 times 10 power of negative 4 inch Hg. So the final answer that you're going to get is 1.11 times 10 power of 5 Newton over meter square. So this is the final answer for question 2. Okay, so for question 3, examine the figure below oil. This is oil that uh, flow from point A to point B with the density given 0.91 gram over centimeter cube flow in a pipe. And the flow rate is measured via a mercury. This is the mercury inside of the manometer with the density of 13.546 gram over centimeter cube. If the difference in height of the two legs of the manometer is 0.78 inch, so the difference. So if this like this, which pressure point is higher? Point A or point B? Anyone want to answer? If like this, which point is higher in pressure? Point A or point B?
Point A.
Point A, correct. That's why it can push down the mercury down more than point B. Yeah. So you need to also understand this concept because it's going to relate to the calculation. What is the corresponding pressure between point A and point B in millimeter mercury? At which point A or B is the pressure higher? Okay, so we already know lah. At point A is higher in pressure. The temperature is 60 degree Fahrenheit. Okay. The reason why it give the degree Fahrenheit, the temperature here is because it's something related to the density. Yeah, because density will change over time, over temperature. Different temperature will produce different density. And for other type of question, maybe you have to refer to the steam table to see the density at specific temperature. For this one, we already have the density. We're just going to use whatever that we have, and just going to ignore the temperature. Okay. So let's just try. This is just using the formula. Okay. So just going to draw again. Okay. So this is the ductile or the pipe in which we have. I'm so sorry because of my drawing. Okay, so we have something like this. This is point A. This is point B. And then the flow will go from point A to point B with the oil density of 0.91. Okay, so it will flow to point B. Okay, so now we have the mercury. Yeah, this is mercury with the density of mercury. So this is the density 2 is equals to 13.546 gram over centimeter cube. This is also gram over centimeter cube. Okay, so the different height here is equals to 0.78 inch. So we have the formula. If you go back to the lecture notes, we have the formula like this. If the liquid in point A and point B is the same, the formula will be like this. Rho 2 minus rho times G H2. Okay, so step 1, We need to change all this to kg. We need to include all the value and change to kg ms power of 2. So let's just do it. Okay, so the density of the mercury is 13.546 minus the density of the oil, which is 0.91. Okay, and this is in gram centimeter cube. Okay, and then we have the gravity. The gravity, for gravity, normally just use the standard one, 9.8 meter second power of 2. Eh? So we're just going to use the standard one, 9.8 meter s power of 2. And then the height, H2, is this, 0.78 inch. Okay. So we need to, can I just continue it here? So this is still the from here. Just going to continue. We need to multiply with, we need to do some of the arrangements so that the unit will change. 1 kg is equals to, we want to cancel this gram to 1 kg. And then we want to cancel the centimeter cubic here. 100 centimeter is equals to 1 meter power of 3. And then we want to also change the inch here to become 1 meter. 39.37 inch. Okay, so we're just going to cancel G with G, meter with meter. Sorry, not this one. Betul lah. Okay. Well, actually, this is power of 3. So, centimeter power of 3. To power of 3. And then meter, meter. Cancel this. Inch, cancel this. Okay. So, at the end, we are going to get the final answer of 2.45 times 10 power of 3 kg over ms power of 2. So, we are going to get something like this at the end. So, this is the first step. But the question asked to change to millimeter mercury, not in kg over ms power of 2. So we need to do the second step. Okay, so this is the first step. And the second step, to change to millimeter mercury. So we have already the value 2.45 times 10 power of 3 kg over ms. Okay, so we are going to do some conversion. 1 kg ms power of 2 is equals to 1 nano Newton over m power of 2. And 1.1325 times 10 power of 5 Newton m power of 2 is equals to 760 mmHg. So at the end, you are going to get the final answer of 18.4 millimeter Hg as the pressure. in the manometer. So this is the final answer. Any questions so far? This is the first step. The first step is to change by according to the formula here, yeah. The formula here just include all the value, and then you need to do some apa some unit conversion, so that you're going to get at the end the final will be in the kg and kgms power of 2. And then from kgms power of 2, you want to change to millimeter mercury. So in my the way I try to solve it, I try to solve it in kg ms power of 2 before I change to millimeter mercury. So that I have two step. But if we want to do the direct conversion also, if you if you can do it, it doesn't matter as long as the final answer will be in millimeter mercury. Okay. So this is for question 3. And for question 4, examine figure below. The barometer reads 740 millimeter mercury. Calculate the pressure in the tank in the PSI. Okay. So like this one, may I know whether the pressure in the tank is higher or lower than the pressure of the atmospheric pressure? Anyone can answer?
Atmospheric pressure is higher.
Yes, correct. So that's why when the atmospheric pressure is higher, that means that the tank is in a vacuum condition. It's almost the vacuum condition because the pressure is very lesser compared to the atmospheric pressure. So that's why the absolute pressure, instead of the pressure of the tank plus the pressure of the atmospheric pressure, it will be different. The atmospheric pressure will be minus the pressure of the tank, so that we are going to get the absolute pressure. Okay, so let's just do it. For question 4, okay, so the basis, I'm just going to see the basis is 20 inch Hg gauge. Okay, jap eh. Oh, okay. So the manometer reading is 20 inch Hg. So we're just going to consider this as the pressure of the barometer, and then the manometer, and then we are going to have the barometer which is having this. So this is the pressure of the atmosphere. This is the pressure of the tank. Okay. So this is the gauge pressure. And then we want to change this to uh did you ask any, or in PSIA? Okay. Okay, so 20, we need to change this pressure gauge 20 inch Hg. We need to change this to PSI. 20 again, this is based on the unit conversion table. Change to 14.7 PSI. So it's equals to 9.83 PSI. And then for the P absolute, which is the barometer reading, is stated 740 mmHg. And we want it to be in uh, PSI. So 760 mmHg is equal to 14.7 PSI. So we're going to get the answer of 14.3 PSI A. Because this is absolute pressure. This is not absolute pressure yet. This is the atmospheric pressure. ATM. So because it's ATM, I already kind of like include A here. So for the P absolute, because based on the figure here, we know that the pressure of the manometer is lesser than pressure of the atmospheric. So that's why the atmospheric pressure will have to minus the pressure of the gauge. So what we have here, 14.3 minus 9.83 psi. And so the final answer will be 4.47 psia. So this is the final answer. Okay. Anyone confused? Why suddenly I minus instead of I plus? Yeah, because if the pressure of the cage, I'm consider this is a gauge pressure lah. Walaupun or even though it's used the manometer, but everything that did not consider the atmospheric pressure is considered as the gauge pressure kan. So that's why the manometer reading is lesser than the atmospheric pressure. So that's why we have to minus the atmospheric pressure at the end to get the absolute pressure. So this is the absolute pressure inside of the chamber, inside of the tank, actually, at the end. Okay. Any question? Um, for pressure, again, you can see there will be definitely a lot of unit conversion. So again, I would like to kind of like remind you to kind of like familiar with the conversion table. Definitely, if I were to ask this kind of question in the test or in the exam, I will check whether the question will be something that you can refer to the conversion table to solve or not. Yeah, for instance, like that inch water, let's say we don't have that in this table, so I'm not going to ask that. But other that you can either find in this conversion table, maybe it will be asked in the test or in the exam, okay? So that's about the temperature and pressure tutorial. And I really hope that instead of just, try to solve this by just copying what I already explained, it's better for you to find out. For instance, like the way I solve this, it's still a very I already use some shortcut. For instance, like the way I convert from Pascal to pound feet square and so on. So you need to find out how this happen. Okay. Similarly, like for the temperature also in terms of the conversion and how the calculation and so on. I wish that you are going to try and to try it and try to do the calculation step by step in detail so that you are going to get more understanding about how to solve this question. And also I would encourage you to also try other kind of like question related to the thing that I've mentioned in this lecture video, uh, because definitely for the test and for the final exam, the type of question will be I will twist. I'm not going to give you straight away the same pattern question like what I asked in test or in the tutorial or in the example given. It's not like the one that you experience during SPM or STPM, in which the type of question will be more or less similar. But in the university level, we try to change here and there so that we want to see whether you just memorizing the step or instead of you understand how to solve the question. We just want to know that. Yeah. If we twist here and there and you just follow the same solution like in the tutorial or in the example, um, then you have some problem lah in answering the question. Okay. So any question? And all of this actually I extract from the textbook, which is the textbook that I mentioned during our first class. So if you got time, if you want to go to the library, uh, or if you can download, you want to buy the soft copy of the book, is okay. You are always welcome to do that. So you can try more question and try to understand the how the solution work. Because I think this is one of the common courses that most of the chemical engineering student will learn throughout the whole world. Yeah. So if you ask student from US or UK or Japan, they will also learn about the unit conversion, the process variable, as well as the mass and energy balance too. Eh? So this very standard way of the syllabus is also about more or less is standard. Eh? Okay. So any question before we end our tutorial? I will share the recorded video of this session later. And I really hope that you will also submit. Let me see imbangan bahan. Okay. So this is the near. Okay. So for the weekly exercise, don't confuse here. Weekly exercise you need to submit according to all the example given in the in the video. And then you need to also submit the tutorial. Okay, let's see for tutorial 1. Oh, sorry. This is EPF31. This is for Zhao. Okay. Let's see. Okay, tutorial 1, you can see 30 out of 41 student already submitted. I'm waiting for another 11 student to submit. So let's just view the submission. Okay, so far you are following the numbering, which is good. Badron, please follow the numbering, yeah. Like your friends here. Similar like AutoCAD too. Just follow what is your number. The number is according to your attendance sheet. I already shared that in the WhatsApp group. Uh, the numbering is according to your attendance. If you are in, let's say, number 11, so just put 11 there. Eh?
Tidak ada.
Okay. And for tutorial 2, I give you until next week on Friday. Ni sama. Wan Ahmad Khalid, please follow the ni the the format of the name of the file as what been asked in the format in the WhatsApp group. Okay.
Later.
And for the tutorial 2, please submit by Friday next week. Okay. So okay, so tutorial 1 last week I gave you 2 video. One is the tutorial that I have conducted in 2020. That was like I think that one is during the pandemic, the first PKP, in which it was, everybody don't know what to do, and I was, and in fact, this video, the one that I provide, is also I already prepared it during that time, during the PKP time, at home. So if you notice, there will be some voices of kids as a background. So I'm sorry for that because that's my kid, and that's happened during the quarantine time, during the PKP. Eh? And I also give you the other video of 2022, the one that had been interrupted by the internet failure. Okay, so later I will also give you the link for the video for today's session, and next week I give you for the tutorial three. I don't know, maybe next week we are going to do it physically. I will try my best to book for a class. Do you prefer to have it live or do you prefer to have it face to face? Because just want to stay in the room because it's puasa kan. Everybody is very, especially because it's petang, is in the afternoon session. So just want to be at your room. Or you prefer to have it face to face? Hmm. No answer. Macam tak nak
Stay
je.
in the room, doctor. Majority, doctor.
Ah,
Stay
majority?
in the
Apa
room,
yang
doctor.
majority? Stay in the room. Oh. I thought you want to have it physically. Okay lah. If you request to have it in the room, so we're just going to have a live session like this for the subsequent week. Maybe later lah after you come back from your mid semester break, then we're going to have a physical class. Okay. And I don't know whether what about the student activity from bahagian Haliwa Pelajar, whether we are allowed to do uh, any industrial visit or not. Because before this, I will try to arrange for at least an industrial visit to go to a food factory around this area. We will book bus, we go to the factory for half a day only. For instance, like may I know for like today's class, do you have any class after this? English class ke apa ke ada tak? Anyone have ada class?
Tak ada dah, doktor.
Zau, how about Zau?
Now,
Huh? No class. Okay, so if we can arrange for to visit to factory, let's say the Cadbury, not Cadbury, Cadbury tak bagi. I don't know. The policy of the company normally we bring our student to Yakult or to Beryl's factory. Beryl's is a chocolate factory in Bangi. Uh, something like this. Just half a day. We will move from UPM, let's say 1:30 or after Zoho, 1:45 or 2, and we reach there, and then we spend 1 or 2 hours there, and we come back before 5. But I don't know. We have to see and what is the university policy uh, at the current moment, whether the student are allowed to go for industrial visit or not. Yeah. At least you can go to some other places lah instead of just stay in your room. Baru menarik. Baru you can relate all of the thing that you have learned with the real industrial environment. Instead of just doing all this calculation and have no idea how to relate this in the real industrial experience. Okay. So I think that's all for this session. Suka ni Liana Okay, Zhao also no class after this. Okay, good. So let's me check that back. I'm not going to give any promise. Let me check whether, and in fact, if UPM allow us to go, I don't know whether the factory will allow us to visit. So there will be a lot of challenges. I'm not going to promise anything, but I'm trying my best to see. Kenapa Cadbury tak bagi visit, Doctor? Well, basically, it's not all the food company allow any visitors to come because they have their own private and confidential things that they want to keep to themselves. So not all the food factory, and in fact, food factory normally really keep their hygiene and cleanliness to the very maximum level. So that's why they don't really favor for strangers to come to their place, because there will be some cross contamination and so on. But based on our experience last time, I bring to Yakult, I bring to Barrel's Chocolate Factory, and also Gardenia. At least these three company allow us to do the visit before PKP, before this pandemic. I don't know after this pandemic whether they still allow us to visit them or not, especially in a big numbers of students. Okay, so I'm not going to promise anything. I'll try my best. Okay, is it okay for everyone?
Okay, doctor.
Okay. Okay, thank you so much. So for those who are fasting today, selamat berbuka puasa and we'll see you again next week, okay? Okay, bye-bye. Bye-bye
thank
everyone.
you, doctor.
Assalamualaikum.
Goodbye, doctor. Thank you, doctor.
Thank you, doctor.